Class, I'd like you to begin with this warm-up. I want you to list the sides of each triangle in order from shortest to longest. So press pause, and when you're ready, press play again and check your answers. Here they are. The very first thing I needed to do was to find the angle measures of each triangle. So you can tell in the first triangle, I added the acute angles together, and I set it equal to 90 degrees. Then I solved for x. I found x was equal to 13. I plugged it in, and then I found each angle measure. I labeled my triangle from small, medium, and large. Small side across from small angle, large side across from large angle, medium side across from medium angle. And then I ordered them. AB is the smallest side, AC is the medium side, and BC is the largest side. In the second triangle, I added up all the angles and set it equal to 180 and solved for x. X was 10. I went back and I plugged in and I found all my angle measures. And the smallest side again is across from the smallest angle, largest side across from the largest, medium across from the medium. So EF is the smallest, DE is the medium, and DF is the largest. The next thing I want you to do is to give this a try. If you remember today, I did a problem like this. Remember yesterday I did a problem like this in class, and I said how important it was that you were going to see something just like it on your test. So I want to make sure that you have some practice with this. So press pause when you're ready to see the answer. Press play again. Here we go. So I found all the angle measures in each triangle, and I labeled all my sides small, medium, large. And if you look at triangle ABC, my smallest angle was angle A, so BC is the smallest side. 60 degrees is the medium angle, so AC is the medium side, and 78 is the large one, AB is the largest side. And then I did the same thing for triangle BCD. Now, when you find your smallest segment, you look around the outside of your figure and you locate the S for small. And the smallest side overall is the segment BD. So you can see I've listed that there. Now this tells me that I'm going to begin listing my triangle sides in order from smallest to largest in this triangle. So BD is the smallest, the next smallest is CD, and then the next after that is BC. Now, BC is the largest side of triangle BCD, and it is the smallest side of triangle ABC. So this acts as my bridge over into the other triangle. And then I just continue in order in the next triangle. And this one. So this is my smallest side. The next larger side, can't talk, is AC, and then after that, AB. Now here are two theorems. We've been working in one triangle, well, with the exception of those past couple problems. Yesterday we talked about inequalities in one triangle. Today we're going to talk about inequalities in two triangles. This is actually section 5.6. And here are the first two theorems. These are called hinge theorems. The first one says if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is across from the larger angle. Now when we say included angles, we mean the angle in between the congruent sides. So if I actually trace over those two sides, you can see that this angle here is the included angle. Same thing over here. Trace over the congruent sides. This angle is the included angle. If I know angle A is larger than angle D, then I know the segment opposite angle A is larger than the segment opposite EF. Notice it is important that these angles are in between congruent sides. The converse works as well. If I know that I have two sides congruent in two different triangles and the third side here, these third sides are not equal, then I know that the largest angle is across from the largest side. So if I know that GH is greater than LK, then I know that angle J is larger than angle M. Pause your video if you need more time to copy this. Okay, so let's see an example of that. If I look at this figure, I'd like to compare angle BAC, this one right here, to angle DAC, that one right here. Now, they're not congruent, but they are sandwiched between congruent segments. This segment's congruent to itself. This segment is congruent to itself. So, the larger angle is across from the larger side. So angle BAC is greater than angle DAC. Now, why don't you guys give this one a try? Press pause when you're ready to see the answer. Press play. Here's the answer. The very first thing I needed to do was I needed to find the angle measure that was not given. You can do this by knowing that these two angles form a linear pair. So this angle right here is 180 minus 82. Now, those two angles are sandwiched between congruent sides. This side is congruent to itself. This side is congruent to this side. So the larger side is going to be across from the larger angle. Here's my larger angle. So the side opposite it is larger. So my small side is EF. EF is less than FG. Here's another one. Now this one involves variables, so it's going to be a little bit different. We're trying to find a range of values for K. The first inequality I want to write is the one that just is so obvious that most people forget. This angle right here is 5K minus 12. An angle has to be greater than 0. So I'm going to write 5K minus 12 is greater than 0. So that's my first inequality. I'm going to write two of them. The next one comes from the fact that this angle and this angle are sandwiched between congruent sides. So if I look at the third sides, I know that the measure of angle L has to be less than the measure of angle, oh, I need three letters. See what happens to me? Let's try this one more time. The measure of angle PLN has to be less than the measure of angle NLM. I ran out of room here, so let's give this a try. Move it down here. What happened to me? Oh boy. Okay, so this is my smaller angle. This is the larger one. So I then know that 5K minus 12 has to be less than 38. So I solved both of these inequality to find the range of values that would allow this triangle to exist the way it does. So we'll add 12 to both sides. K is less than 50, so K has to be less than 10. Now over here, we're going to add 12 to both sides and divide both sides by 5. So I know that K has to be greater than 12/5 and less than 10. I'm going to draw that on the number line just so I can see it a little bit better. Here's 12/5, and here's 10. It has to be greater than 12/5, and it has to be less then 10. That happens in between those two values. So I know that k has to be less than 10 and greater than 12/5. And that is my answer. Give this one a try. Press play when you're ready to see the answer. I would like to know how the measure of EGH relates to the measure of EGF. And here's the answer. Again, notice that those two angles are sandwiched between two congruent sides. This one, EG, and FG is congruent to HG. Give this one a try. I would like you to compare segment BC and AB, the lengths of them. Press pause when you're ready to see the answer. Press play. Here we go. The shorter side is across from the smaller angle, larger side across from the larger angle, so AB is less than BC. All right, the next thing I want you to do is I would like for you to try these 3 problems. Press pause when you're ready to see the answer. Press play. And here are the answers. If you got something different, go back and check your work. Notice that for number 3, I made sure to write that each, I believe those were angle measures, were they? No, sides. Each side had to be greater than 0, so I was able to find a range from -3 to 7. That is all I have for you today. Check Schoology for your assignment and have a wonderful night. I'll see you tomorrow.